Okay, number 5 is not too bad. So basically we have our skier. He's on this slope and they say it's 170 meters. So that's how tall this slope is. Now, what we want to figure out is his acceleration. Based on this limited information, the only thing we could think about using is the kinematics normal formula. So let's use it. The change in y, the displacement, equals 1/2 at squared plus VOT. Well, we know that this skier starts out with 0 velocity, so that becomes 0. We know he'll travel 170 meters in 66 seconds, right? So that's your 170 meters. That's the total displacement, equals 1/2 a times t squared. They said the old ski is 66 seconds, so you just substitute that in for t. Remember, the acceleration, it's not g. There's friction involved, there's this, there's that. You don't know what the acceleration is. You're trying to solve for the acceleration. So then you just solve for a. And you could just do the same thing for b, except use the new time. Now for part b, they told you that the slope is 3 degrees. So we set up our normal force body diagram, mass times mass gravity pointing down, and then you have mg sine theta here, you have mg cosine theta here, and then you have kinetic friction. And so you're trying to calculate the kinetic friction, right? So this is how I set up my axes. So now you have sum of the forces in the x direction equals mass times acceleration. Again, this a is not 0. This guy's moving, he's accelerating. This a is not 0. So what are the forces in the x direction? Mg sine theta is the one going down parallel to the slope down this way, minus kinetic friction, mu k mg cosine theta. Remember, the kinetic friction amount is going to be what's pushing into the plank, the hill, whatever it is. So this is what is pushing into it, mg cosine theta. And that equals mass times acceleration. Now you just cross out the m's, you get g sine theta minus mu k g cosine theta equals a. You have theta, which equals 3 degrees. You have g. You're trying to solve for mu k. You have a. A is what you got in this previous part. So you just plug that acceleration in and you get the new kinetic friction.